Hello everyone, this is Mr. Appel, and we're going to use the conjugate root theorem, which is just fancy talk for dealing with i's, and all it really says is that if 2i is a 0, then negative 2i must also be a 0, because the only way you get i's is with square rooting negatives, and when you square root both sides of an equation, you get a plus or minus. But it looks a little weird, but I'll show you how it's done. It's actually kind of cool. So I'm going to show you using synthetic division. So I'm going to use the 0 that I have, the first one being 2i. We're going to do our synthetic division just like we would if I gave you a real number. So I'm going to bring down, I'm going to multiply 2i times 1 is 2i. Now when we add, they're not like terms, so it looks a little funky because we have negative 3 plus 2i. But now when we multiply again the 2i by the negative 3 plus 2i, 2i times negative 3 is negative 6i. But 2i times 2i is 4i squared. And 4i squared, remember, is negative 4, because I squared is negative 1. And so now when we add that next column, the 4 and the negative 4 cancel out, and we're just left with a negative 6i. Multiply again, 2i times negative 6i, which is negative 12i squared. Negative 12, I'll write this one out, I squared. But I squared is negative 1, so that becomes positive 12. And so when you add them together, you do in fact get 0, which we expected. Now I'm going to take those remaining coefficients, and now I'm going to do synthetic division using the negative 2i, because they actually gave you 2 zeros in one. And we're going to just follow the same process. Again, it looks a little wonky, but it's not so bad. So we bring down the 1, we multiply negative 2i times 1, which is negative 2i. We add, and notice that the 2i's cancel, and it just left with a negative 3. Then negative 2i times the negative 3, which is a positive 6i. And as we expected, we do in fact get a 0. And then we'll see what's left over now. 0 is the remainder, negative 3 is the constant, 1 is the coefficient on x. So we're left with x minus 3, which is a linear factor. And so the final 0 then is x equals 3. So since we were asked to solve our zeros, we usually like to write the reals before the fakes, so real before the imaginary. So we have 3, negative 2i, and positive 2i, and those are our zeros. That's all for now. Thanks.